Anshu and today I will discuss about the assignment 2 of CML102. In this we have to perform three tasks. First one is to use OLX2 software to solve and refine the crystal structures for the provided data sets. And the second one is to create crystal packing diagram for each solved structure using Vesta. And the third one is to simulate powder XRD patterns for each solved crystal structure. For these three tasks, we will use two softwares. First one is OLX2 and second one is Vesta. We use OLX2 to solve and refine provided crystal structure and Vesta to generate crystal packing diagrams and simulate powder XRD patterns. In this, we have data provided of three compounds. First one is hydrochlorothiazide, second is riluzole malonic acid, and third one is for riluzole orthophosphoric acid. All these datasets are present as .ins file which we will give to OLX2 software, and it will plot electron densities in space, and we will use hit and trial method to uh, assign each electron density to particular element like fluorine, oxygen, carbon, etc., and see whether this calculated structure resembles with the observed structure. And for that we use a parameter known as R factor. The R factor is represented as this: F observed minus F calculated, sum modulated means positive sum of all the values in all the HKL planes divided by the all the structure factor observed values in all HKL planes. This will give us R factor. The lesser the R factor, the better the structure we have formed. And for the task 1, we will use OLX2 software. As you can see, this is for hydrochlorothiazide structure. In this, we can use this type of knowledge from the structure, that how we in which position our carbon, chlorine, sulfur, nitrogen, etc. are present. Like a carbon ring present here, a chlorine and sulfur present, and we can see also that this is a carbon ring and a yellow sulfur present, and here a chlorine, green chlorine present, and then we can form this structure. And this is for hydrochlorothiazide, this one is for riluzole, and this one is malonic acid. In malonic acid we have three carbons, and this is double bonded oxygen, this also double bonded oxygen, and this is two are hydroxide groups, and we can see that there is a hydrogen bonding, but there is no hydrogen bonding between these two because this is fluorine and these are oxygen, so there is no hydrogen bonding between them. And in case of the orthophosphoric acid present, we have hydrogen bonding because this is hydrogen, this is oxygen, so they will hydrogen bond with each other. We can also show how we can uh, form this structure. For that, initially we had all the electron densities present like this. We can see that this is a carbon ring present here, so we can select all these electron densities and call that these are carbon. And then we have in riluzole we have, as we can see, uh, oxygen and one carbon and three fluorine. For that we go to it there and we say that this is nothing but oxygen. So oxygen here, and this one is carbon, and these three are fluorine. So on the other hand, we have a sulfur on the oxygen side, and this one is phosphorus. This one is nitrogen. Sorry. So we can select it again and say that this is nitrogen, and atom present between them is carbon, and with carbon we have bonded nitrogen. So we can select this high density. As we can see, this light one are hydrogen because they have less electrons, only one electron in shell, outer shell. But like this, uh, nitrogen has seven. So this is more darker than the hydrogen one. And as this is represented as sulfur, like sulfur, but this is not actually sulfur. This is phosphor for orthophosphoric acid. As sulfur has 16 electrons and phosphorus has 15 electrons, so this OLX2 software was not able to distinguish between them. So we can say that this is phosphorus, and the higher electron density four spheres are nothing but oxygen. So this is the basic structure. And now we can say that these are using, because of thermal vibration, we can say that these are ellipsoidal. So we can uh, tell them they are ellipsoidal and add hydrogen. So OLX2 uh, add hydrogen by itself. So this is the structure formed. And the R factor, we can use the refine to see the R factor of the structure, and it is coming out to be very less. And also this is a extra hydrogen, so we can delete them, and increase the this will decrease the R factor. Now, no, this has increased the R factor, so we this is also hydrogen, so we can say that this is hydrogen. Now we can use the refined. Like, yeah, this is 3.3 now. So as you can see, this is our formed crystal structure, and with R factor of 3.3, which is very low. So this is how we can use OLX2 to solve the structure. And also when we have added ellipsoids instead of sphere, the R factor reduced from 7 or 8 to 3 or 4, which is very good. And we can save this as .cia file, which we will use in next task in Vesta. For our cases, firstly, R factor was coming out with 3.76 for hydrochlorothiazide, and for riluzole malonic it was 3.7, and for the third one it was 3.3. And these are the three structures, and one of which I have made in this video. Second task is to create the crystal packing diagram, which we will use for which we will use Vesta. In this, these are the three compounds crystal packing diagram, and in this we have five different hydrochlorothiazide molecules in one unit cell, and we can see that there are bonding between them in the crystal packing structure. And for visualizing along A axis, we can click on A in Vesta. So this is C axis, this is B, and the axis along which we are viewing it is nothing but A axis. This is view is for the B axis, and this view is for the C axis. Similarly, for second and third compound, we can visualize all these. And as we can see, these are the all the crystal packing diagram for all three compounds along A axis, B axis, and C axis. The third task is to simulate the powder XRD pattern. So with the crystal structure determined, the positional information of the atoms within the lattice is now available. And we will utilize the powder diffraction pattern simulation feature in Vesta to generate the powder XRD pattern for each crystal. So in Vesta we have, if we go to utilities and click on powder diffraction pattern, then we will be able to see the Let's try for this one. If we click, so this is for the liluzole and malonic acid, the powder diffraction pattern. So this x-axis is in degree, which is 2 theta. Theta is the angle along which the we uh, scatter the light on the powder crystal, and the y-axis is for the intensity. How intense at particular 2 theta angle we obtain the uh, like intensity we obtain X-rays. So the high the intensity shows the more the scattering along that plane. This all these peaks shows for different planes, different HKL planes present in the structure. So we can also like zoom in this particular area, and we can see that one peak at this particular 8 to 9 degree, and like these are all are HKL planes. Similarly for the first and third one we can plot, and these are shown in the doc file. So this was the assignment in which we have seen how we can use the .ins file to plot the structure and then visualize them in the OLX2, and also we can plot the powder XRD pattern for the datasets. Thank you.